Hey YouTube, this is my first video in a module I'm doing on the quadratic formula. And basically what I want to start by saying is this: if we solve the equation ax squared plus bx plus c equals 0, and we leave a, b, and c general, that is, we just let them be variable values and not numbers whatsoever, and we solve this by completing the square, what we're led to is a general solution that says, well then in this case, given a, b, and c, x is always going to be equal to this, given that you started with this equation in the first place. And so what it is that we're finding there is actually what we call the quadratic formula, this general solution to some quadratic equation in standard form where it's equal to 0. And so we're going to allow a, b, and c to be real numbers such that our a value isn't 0. We say the solutions of the quadratic equation here are always going to be equal to these right here. The only stipulation is that we can identify a, b, and c, which are pretty easy to do. So what I'm going to do in this video is not so much kind of detail why this is the set of solutions right here, even though I've just kind of mentioned it. You complete the square with the statement up here, but more I would like to focus on how you use it to find the solutions to a quadratic equation in standard form. So what we're going to do is we're just going to look at 3 examples and then justify our answers using a graphing utility. So I want to do this. I want to use the quadratic formula to solve the following quadratic equation, then use a graphing utility to support our answers. Okay, so recall that the quadratic formula here, this formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Takes a minute or two to memorize it, but then you get it down. It only works though if it's in standard form. The equation's in standard form and set equal to 0. So when you're using the quadratic formula, keep in mind that the very first thing we want to do is make sure that we have it in standard form and that it is equal to 0. And the next thing we're going to do is we're going to identify the values of a, b, and c, and we can just list these off on the side. So it seems that our a value here is 3, our b value is 4, and then our c value is negative 10. But now that we know these values, what we're going to do is we're just going to go substitute them into this quadratic formula. So I'm going to use a lot of parentheses here. We have negative b plus or minus the square root of, now we'd have b squared minus 4 times a times c, and this is all over 2 times a. Where in these first 2 blanks here, we're going to put our b value, which is 4, and then another 4. These 2 blanks here, we'll put our a value, which our a value is 3, and then we have another 3. And then last but not least, we have this negative 10 that only hangs out in this one spot inside the radical here. So we're going to simplify this, but essentially what I have to tell you is right now, these are the solutions right here. This is the set of solutions right here, no matter what. It's just that we like to simplify things. So we have negative 4 plus or minus the square root of something, and this is all over 2 times 3, which is 6. So I do want to mention that the 2 easiest parts of this whole formula to tackle are the negative b part and then the 2a part. Probably the most complicated part is what's inside this radical right here that we'll later call the discriminant. So let's go ahead and simplify it. So I noticed that 4 squared, this first number inside the radical is always going to be a positive because we're squaring that value. So we get a 16. And then the other thing I want everybody to notice is this other product over here, it says minus here, but I want you to look at this as this negative is attached to this 4. And I would say a negative 4, a positive 3, and a negative 10. How many total negatives are there? And I count 2. Well, 2 negatives, what this means to me is multiplying wise, we're going to get a positive result. And so I'm going to put that positive there now, and then I'm just going to worry about what 4 times 3 times 10 is, which is a 12 times a 10, which is 120. So what we're going to do here is we're going to just keep simplifying. We say negative 4 plus or minus the square root of, it looks like 136 all over 6. So now I might be curious, are there any perfect squares that go into 136? So maybe we take 136 and we divide it by, I don't know, like 25. And I know the 25 is not going to work, but just to show you that we're going to take this 136 and divide it until we find the biggest perfect square we can find to go into it. We'll try 16. 16 doesn't go into it evenly. How about 136 divided by 9, which is a perfect square? That doesn't work. And then 136, which I suspect 4 goes into it, but we say divided by 4, would be really 4 times 34. So what we end up with here is this negative 4 plus or minus the square root of 4 times 34 all over 6. And what we're going to do is we're going to say that I know the square root of 4 is 2 and put that out front. So simplifying the furthest, we'd say negative 4 plus or minus 2 times the square root of 34 all over 6. And I notice that the negative 4, the 2, and the 6 all have a common factor of 2. So we can reduce those all by a factor of 2, divide a 2 out of each, and we get negative 2 plus or minus 2 divided by 2 is 1. So we just have the square root of 34 now. And this is all over 6 divided by 2, which is 3. This would be our set of solutions right here. So when I said let's go justify this with a graphing utility, what I'm going to do is I'm going to cheat a little bit here. I'm going to use Desmos. And so we'll type in the equation that we were given in the first place. And I just want to show you this here. So our beginning values are 3, 4, and negative 10. So this is going to be 3x squared plus 4x minus 10. And we get this parabola here. But what I want to point out is what we were solving for were the solutions of the zero. So I get this 0 here and this 0 here. So now furthermore, we'd say we had negative 2 plus or minus root 32 over 3. I'm going to pull some magic here, but we'd say negative 2 plus the square root of 34. Oops, we'll do this. This divided by 3. And then I'm just going to copy and paste this down here. And we'll go back and we'll make this a negative here. But our two solutions are with both a positive and a negative here. You notice that these are the exact same decimal values that you're seeing on the x-axis. So the beneficial thing about using the quadratic formula is that it leads you to the solutions no matter what. Even if this had been factorable or not factorable, you're always going to get these as solutions so long as you have this written in standard form set equal to 0. So these last couple of examples, we're just going to tackle these really, really quickly. I'm going to move fast here. So we'd say A, B, and C. And I would encourage you to pause this and try these on your own first. But we'd say A here is 1, our B value looks like negative 6, and our C value is 4. So again, our solutions, since I noticed this is already set equal to 0, is going to be negative B plus or minus the square root of, and we have a B squared minus 4 times A times C. This is all over 2 times A. So dropping in our B first, we get a negative 6 and a negative 6. Our A value next is a 1 and a 1, and then we have a C value of 4 here. So solving this here, we get a negative 6 is a positive 6, and then in the denominator we have a 2. So now we're going to tackle the stuff inside this radicand, where we have a negative 6 squared, it's 36. I only count one negative over here, so this whole product must come out to be negative, and I know that 4 times 1 times 4 is 16. So reducing this further, we'd say 6 plus or minus the square root of 36 minus 16 is 20. This is all over 2. And I know that a perfect square that goes into 20 evenly would be 4. So we're going to reduce this radical over here, and I would say that we could take the square root of 4 out front. And so we end up with this 6 plus or minus 2 root 5 all over 2. And I also notice that all three of these terms are even. So I can say reducing these by a factor of 2, this would become this on top and just a 1 on bottom. But we would get 3 plus or minus the square root of 5. And again, if we go graph this here, we have x squared minus 6x plus 4. Let's go ahead and graph this here. We have x, get these out of here. X squared minus 6x plus 4. We'll look at its zeros, its roots, and we were able to determine it was 3 plus or minus the square root of 5. So let's type in 3 plus the square root of 5, and then we'd have 3 minus the square root of 5. Oops, 5. And you could see that these are indeed the same two values that we're getting over here exactly. So for this last example here, let's go ahead and start by setting this equal to 0 first. We want to set it equal to 0 first. So I'll get my pen tool out here. And so we'll move this 7 back over. So we'd have 2x squared plus a 7x plus 4, and this would be equal to 0. So again, A, B, and C are the values that we need here. So we'd say A is 2, B is 7, and our C value is a positive 4. So we're going to keep these handy. And we say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, try this on your own first, but see what I get here. We say 7 and 7, 2 and 2, and then our c value go in the back here, 4. But reducing this, we would get a negative 7 in front, plus or minus the square root of, and this is all over 4. And then inside the radical, we get 7 squared is 49. I count one negative altogether, so it'll be a subtraction here. And then 4 times 2 is 8. 8 times 4 is 32. So we end up with this here. We get negative 7 plus or minus the square root of, I count here, 15. And this is all over 4. And we would just say that those are the solutions right there. And I would encourage you to go check them graphically. Cheers.